Did you know that developers on average spend almost a third of their work week debugging? That's hours lost to hunting down edge cases, chasing down bugs in unfamiliar libraries, and wrangling messy code instead of shipping features. What if you could pair with a coder who not only writes code faster, but also reasons through problems, explains the changes, and keeps you out of risky pitfalls? Today we're diving into a head-to-head comparison that actually matters in a real studio: Claude Code versus GPT Codex. If you're a solo developer, a student, or part of a team trying to scale your coding velocity without sacrificing quality, this video is for you. Let's set the scene. You've got a project that's grown into a small beast, a data pipeline that ingests user events, processes millions of rows, and feeds a dashboard that determines business decisions. The team wants a feature to support more complex data transformations, plus robust error handling and faster execution. You're juggling time, performance, and correctness, and you're tempted to lean on an AI assistant to accelerate everything. But not all AI copilots are created equal. Some are great at spitting out code, others are better at reasoning and safeguarding your project from risky changes. So which one should you actually reach for? Claude Code or GPT Codex? Let's first zero in on the core problem here. When you code with AI assistants, you're not just asking for lines of code to appear, you're asking for a partnership that can understand context, anticipate edge cases, explain your choices, and help you navigate the trade-offs between readability, speed, and correctness. The tool needs to handle multi-step problems, offer safe suggestions, and integrate smoothly into your workflow so you don't fight the tool every time you want to make a small, thoughtful improvement. And of course, you want to know how they behave in the real world, how they handle large files, how they explain their output, how they translate your intent into code across popular languages and frameworks, and how much cognitive load they save you without introducing new risks. That brings us to the solution side: Claude Code and GPT Codex. Both are designed to help you write and understand code, but they lean into different strengths, have different workflows, and shine in different scenarios. Here are the most important features you'll likely care about, broken down side by side so you can decide which one fits your needs best. Claude Code's strongest features. First, Claude Code is designed with a strong emphasis on reasoning and safe, explainable outputs. When you prompt Claude, you're not just asking for a copy-paste solution, you're inviting a detailed, often step-by-step rationale that helps you understand why a certain approach is better for your problem. This is especially valuable when you're working on algorithms, data pipelines, or architecture changes where edge cases matter. Second, Claude Code tends to excel at multi-step tasks and complex transformations. If you're refactoring a function, rewriting a module to embrace a new design pattern, or walking through a difficult bug with a long trace, Claude's reasoning-oriented outputs help you stay in control and avoid magic fixes that look good but break later. Third, its outputs often come with easier-to-understand explanations and justifications. You can ask for clarifications, alternative approaches, or the trade-offs of different strategies. This makes it a strong partner for learning, collaboration, and code reviews, because you can keep a clear line of reasoning for yourself or your teammates. Fourth, Claude Code emphasizes safety and guardrails. In situations where you're dealing with sensitive data, permissions, or security implications, Claude's design tends to steer you towards safer patterns, more explicit input validation, and clearer handling of potential vulnerabilities. Fifth, the tool is generally language agnostic, with a focus on helping you produce clean, maintainable code across languages. It's comfortable working through Python, JavaScript, Go, SQL, and more, while keeping a consistent approach to style and readability. GPT Codex's strongest features. Codex, powering GitHub Copilot and the broader Codex family, is built for speed, breadth, and seamless IDE integration. It's designed to be your constant coding companion inside your editor, whether you're in VS Code, JetBrains, NeoVim, or another popular environment. The most impactful features here are, first, massive language and framework coverage. Codex supports dozens of languages and a wide array of libraries and frameworks. Whether you're prototyping in Python, building a backend in Node.js, or doing data work in SQL and Spark, Codex has seen a lot of it and can generate plausible, idiomatic code that fits the ecosystem you're in. Second, real-time, context-aware code completion inside your IDE. Copilot doesn't require you to leave your editor to ask a question. You write a comment or start typing, and Codex suggests entire blocks of code, small helpers, or test scaffolds. It's especially strong for boilerplate, repetitive patterns, and quick scaffolding, letting you focus on the unique parts of your project. Third, practical productivity features like doc generation, tests, and translation. Codex can generate doc strings, outline or convert existing code to alternative languages, and draft unit tests or property-based tests. In many teams, that means faster onboarding for new contributors and better coverage for critical modules. Fourth, multi-solution prompts and refinement. Codex frequently offers several candidate completions, letting you pick the one that aligns with your style or refactor path. You can tweak the prompt to nudge it toward cleaner architecture or more concise code, then compare options side by side. Fifth, strong IDE tooling and ecosystem integration. Copilot is deeply integrated with popular IDEs and toolchains, which reduces friction and speeds up your day-to-day work. The ability to generate code right where you're reading and editing code is a powerful advantage for rapid iteration. Now that you've seen the features, let's walk through a practical, real-world flow so you can picture yourself using each tool on a typical project. Imagine you're working on that data pipeline and you want to add a robust data validation step before the transformation stage. Your goal is to make the input data contracts explicit, catch malformed rows early, and keep performance in mind. With Claude Code, you'd likely open a chat or prompt window and say something like, "Claude, I need a data validation module for a CSV pipeline. Validate that required columns exist, types are correct, and there are no nulls in critical fields. Also explain your approach and highlight potential performance bottlenecks." The assistant returns a structured plan, an outline of validation steps, a proposed Python module, and inline explanations about why each check exists. Then you might ask for a concrete implementation in Python that uses pandas or a streaming approach if memory is tight. Claude would propose code and explain why it's robust, perhaps pointing out edge cases like empty files, mixed type columns, or large numeric ranges. If you want more detail, you can drill down, show me a version with minimal memory footprint and streaming validation. Claude then adapts, providing a version that uses generators, lazy evaluation, and chunked reads, all with rationale. Imagine you want to compare different approaches. Claude can walk you through the trade-offs, a strict in-memory validation path versus a streaming approach that uses chunking and incremental checks. You can ask for alternative designs like validating with a schema-first approach using libraries such as Pydantic or Good Tables, and Claude will lay out the pros and cons, including how the chosen design affects CPU usage, memory footprint, and error reporting. Now switch to Codex in the same scenario. You're in VS Code, you comment your intent, and add a CSV data validation step with chunked streaming, keep memory under control, return detailed error messages. Codex inspects the surrounding code, your imports, the current function, and the pipeline's shape, and pops out several plausible implementations. You'll often see a few options: a straightforward pandas-based validator for moderate data sizes, a streaming approach that uses iterators and chunk processing for large files, or a schema-driven validator leveraging something like Pydantic or Cerberus for stricter schemas. You can press a key to view different suggestions, cycling through them, and you can accept the one that fits your style. Codex can also propose test scaffolding quickly, like a handful of unit tests that cover missing fields, wrong types, and edge cases like empty files or files with extra columns. In terms of debugging, Codex can help you explain what a failing test is telling you. You can prompt it with, "Help me interpret this assertion error and suggest a fix." Codex tends to give you concrete code edits right in the editor, which you can accept or refine. If you're trying to improve performance, you can ask for a version that minimizes memory usage while preserving the same validation results. And Codex will typically propose streaming reads, chunking, and lazy evaluation patterns. It's fast, which can be a huge advantage when you're under a tight deadline to push a change to production. What about the demo side by side? Claude Code's chat-based approach shines when you want more than just generate this snippet. You can ask questions about the design, request comparative explanations, and get a narrative rationale for each change. It's like having a senior reviewer who not only produces code, but also teaches you why the code is written this way with guardrails and explanations that you can follow in a review meeting. That can be incredibly valuable in teams where onboarding and code provenance matter. Codex excels at speed and in-editor productivity. You'll see more code appear in real time as you type or as you request more options. If you're a fan of a hands-on, iterative workflow, cycling suggestions, testing quickly and refining until you land on a solution, Codex delivers a frictionless, immersive experience. The risk here is that you might end up with options that sound right, but need a careful review to ensure correctness and security. That's where a strong developer discipline comes in. You use the AI as a first-pass partner, then perform your own validation and tests. Let's talk pricing and plans because you'll want to know what it costs to trust these tools with your codebase. Codex via GitHub Copilot generally offers a free trial and then a paid plan, commonly around a modest monthly rate for individuals with higher tiers for teams and enterprises. There are often free options for students and educators, plus sometimes bundles with IDEs or cloud credits. In practice, a lot of teams price Copilot per user per month, and many developers find the ROI is measured in hours saved and fewer context-switching breaks. Claude Code, by contrast, tends to be bundled into an API-based pricing model. You're paying per token, generation, and completion. In practice, that means you can scale usage up or down depending on your code volume and the complexity of the prompts. There's typically a free trial or credits for developers to kick the tires, after which you pay for what you use. The nuance here is that Claude's pricing can feel more granular because you're paying for the depth of reasoning and the length of each interaction, which is great for longer tasks and heavy lift refactoring, but you'll want to monitor usage if your project has tight cost constraints. So which one should you pick? If you crave deep reasoning, explicit explanations, and safer suggestions for architectural changes, Claude Code is a compelling partner. It's the kind of tool you'd invite into architecture reviews because it patiently explains why it suggests a given approach, flags potential pitfalls early, and helps you maintain a high level of code quality as the project grows. It's especially helpful when your work involves complex data processing, algorithmic logic, or when you're learning and want to see the reasoning behind each change. If your primary goal is raw speed, broad language coverage, and seamless in-editor generation, Codex continues to be a powerhouse. It's the classic choice for getting a lot of code written quickly, scaffolding projects, and boosting your day-to-day productivity inside your preferred IDE. If you're a team that wants a steady stream of inline suggestions, fast iterations, and a straightforward billing model, Copilot and Codex are hard to beat. You also get the benefit of a large ecosystem and established integrations with your existing tools. Let me give you a practical recommendation based on different work styles. You're a solo developer who loves learning while you code, wants to see the why behind changes, and values thoughtful guidance. Claude Code is your friend. It helps you grow as a coder, not just generate code. You're under pressure to ship features quickly, you work in a big team, and you rely on your editor to guide you with minimal friction. Codex Copilot is the pragmatic workhorse. It reduces context switching and accelerates your iteration cycle. You're in a hybrid scenario. You want both. You can use Codex for rapid drafting and scaffolding, then bring Claude Code in for the design critique, edge case analysis, and to validate the approach before you commit to a major refactor. The synergy could be very powerful, especially on complex pipelines or data-heavy systems. Now about the affiliate angle. If you're curious to test these tools in your own projects, I'll drop the link in the description. I'll also share tips on how to set up a lightweight workflow to compare them side by side in your own repo, so you can see which one actually saves you time over a 2-week sprint rather than just in theory. I'm not forcing anything, just giving you the